So we start with the partial fractions, and 5 over 2 plus x squared upon 3 plus 4x squared will be ax plus b plus cx plus d. Now we need to multiply through by the common denominator. So that gives us that 5 equals ax plus b, remember your brackets, upon 3 plus 4x squared plus cx plus d upon 2 plus x squared. I'm going to think about solving this by thinking about coefficients. So if we take first of all x cubed, on the left hand side we have 0, and on the right hand side we'll get x cubed by multiplying ax by 4x squared, so that gives us 4a, and we'll also get it by multiplying cx by 1x squared, so that is going to give us c. If we then think about the x squareds, and the x squared will be on the left hand side 0, and on the right it will be 4x squared times b, so that is 4b, and d times x squared. If we then think about the x's, they're going to be 0 as well, and they'll come from the 3a and the 2c. And then if we think about the constant, 5 has to be 3b plus 2d. So we have that 0 is 4a plus c. If I multiply that by 2, 0 equals 8a plus 2c. And we have also that 0 equals 3a plus 2c. Taking those away from one another, we get that a is 0. If a is 0, then c is 0. And that leaves us solving 4b plus d, which I'm going to multiply by 2. So that's 0 equals 8b plus 2d. And 5 equals 3b plus 2d. Subtracting those, minus 5 equals 5b. So b must be minus 1, and if b is minus 1, then d is 4. So bringing all that together, our equation is minus 1 over 2 plus x squared plus 4 over 3 plus 4x squared. So if we now take this, we have dy over dx plus 1 over xy equals 4 upon 3 plus 4x squared minus 1 over 2 plus x squared. We now need to integrate the coefficient of y, and if we integrate 1 over x, we get ln x, which means that we want to multiply through each term by e to the power ln x, which is x. So that gives us x dy dx plus y equals 4x over 3 plus 4x squared minus x over 2 plus x squared. Left hand side is the differential of x times y, and what we're going to do now is integrate the right hand side. I have 4x squared on the bottom. If I differentiate that, I get 8x. So if I make my top 8x, I want half of that. I now have a function and it's differential, so when I integrate it, I'm going to get the natural log of 3 plus 4x squared. If I repeat this with the next integral, I want to have 2x on the top, which means I have to multiply by a half, so I have minus a half the natural log of 2 plus x squared. So x times y equals, and then our constant of integration. If I look at the mark scheme, what I can see then is the only difference between what I have and what they have is they have divided through by x. And they have also used their rules of logs to combine these into a fraction, because when we subtract we can divide.